All right, let's go ahead and start. So basically, thanks for coming to this seminar. Um, I'm gonna kind of go over some of the work that I've been doing to containerize and set up the global workflow so we can run it as a containerized application. And so hopefully you will find it interesting and helpful if you are trying to port to a different machine, or working. You can often use this system on a smaller like desktop machine or something like that. I'm actually going to run it today on a Linux workstation out of EMC. So we'll start going through some of the specifics here. So first of all, just an overview of what the motivation for this, and then some of the specifics. So I mean, basically, it's become pretty apparent that asking general users outside of NOAA to build spack-stack so that they can run UFS applications is a really big hurdle to overcome. So by providing a container that has spack-stack already built into it, this sort of eliminates that problem. Try to design these containers to look as much like a tier 1 platform as possible. So because of that, they're kind of big. They're not streamlined like some containers are. But when you shell into it, you have spack-stack installed. You load modules just like you would on Hera or some other tier 1 platform, and you can build. They come with basically with Intel compilers, Intel MPI, all that stuff, and then spack-stack built in. And clearly the idea here is to simplify the process of porting to generic systems. So I've been kind of working back and forth with Ben Cash on getting some of this to work for him, and it proved to be pretty successful for him, and that felt it's like, okay, this is a reasonable approach to take. So really the idea here is to get non-NOAA researchers working directly with UFS applications, and the more we can get people involved, I think the better off we'll all be. So in the specifics here, like this container that I'm going to use today is based off of spack-stack version 1.8. Global workflow is not fully vetted to work with this version yet or anything, but it does run through this scenario that I'm working with today, and I figured that might as well start with the latest version of spack-stack, and then eventually I'm sure that the global workflow will be adapted for regular platforms to be using these newer versions of spack-stack. You can build the container yourself from a Docker image, which are publicly available. We also have put it into an S3 bucket, so you can download it directly from there. You can copy it over from a tier 1 platform if you wanted to. I've added in a script which I'm calling like externalize. So basically, once you shell into the container, you're going to build your software there, and then you can run this externalized script, which will basically create wrappers for these executables that can be run on the host system. And this is the way, like, I'm trying to get the global workflow to operate on, in a containerized fashion. When you build the global workflow, on a regular system, a tier 1 platform, it puts all the executables in global workflow / exec. And so what we'll be doing is we'll be building those executables. We'll move the actual executables into a different location, but then we'll create the wrappers under that global workflow / exec. And so, like, from the host system, global workflow is going to look at it and say, oh, I see an executable in exec. It's UFS model .x or whatever, and you can run it there on the host system with MPI exec or with srun, and the host system doesn't know any different. Just thinks it's a native executable. So one other caveat here is it's still a work in progress, so not everything works. The things that I'll show you today work. Forecast only scenario. I have run through cycling on a platform that has all of the data. So I've run it through on like Hercules and Gaia using the containerized executables, but haven't completely gotten figured out exactly what data needs to be where for people to use if you wanted to try that out. You're certainly welcome to try, and I encourage people to do so if they're interested, and we can try to work through how to get the extra data that you'll need. So a few assumptions before we kind of get going. So these are things that you are going to need on your host system that if you're going to run this. So first of all, you need to have Intel MPI is probably best. Should work with MPitch also. Gaia has MPitch, for example, and we can run this the containerized executables there. You have to use srun instead of MPI exec. That's fine. Everything seems to work just fine that way. You're definitely going to need Singularity or Aptainer, and currently you need several hundred gigabytes of free space to put all the fix files and other things. Probably don't need quite that much for these smaller like C48, C96 cases, but again, I haven't had, this is part of the work in progress, haven't gotten that list of files completely pared down so that it's easy to just download only what you need. So you're probably going to end up downloading a lot more than what you really need for this particular case. So also some of the preferred things, well, you're going to want to have probably at least 8 cores available to do computation. I can run through, on my desktop or the EMC desktop computers, which have either 8 or 16 cores. That seems to work fine for this case. It'd be good to have Slurm installed. You can use this Rakoto fake Slurm, which is what I'll actually use today. You can get that from the UFS SRW SR Weather app. You should have Rakoto installed optimally, and be able to install either a virtual Python environment or be able to install your some extra Python packages, which you may not have by default, because keep in mind, like the global workflow parts are, the scripting part is all going to run, or mostly going to run, on the host system. So you need to have some basic stuff set up there. There are things you can externalize from the container and run. So for example, prod util, you can externalize that and put that in your path, and so all those tools and scripts that are in prod util will run the containerized version, so you don't have to have that installed on your host. And we'll kind of get to some of that in a second. So first of all, to get the container, as I mentioned, you can build it on your local machine. I got the command right here. Building, usually you can often run into problems if you don't have enough disk space in your home directory, and you have to set some special environment variables to make sure that works. But it's definitely possible, and you can do it without root as well. You can copy it over from the tier 1 platforms. These are the directories where you can find them. But probably the easiest thing is just to copy it, download it from S3. Eddie put a number of, like, I think 3 containers up there, versions, spack-stack versions 1.61, 1.7, and 1.8. Like I said, we'll be using the 1.8 version today. Then here's where the data comes in. Definitely, like this first, the fix files, if you go and just download the entire fix directory from S3, it's like 500 gigs. So you aren't going to need all that, but that's what you'll get if you run this command. I have some some specifics later on in the presentation that kind of will help you cull down that if you don't have that much space available right off the bat. You're also going to want to download like these initial conditions directory. These are a lot smaller because it's really just for the C48 runs in this particular case. If you are interested in doing, higher resolution cases, there are some other things available in this S3 bucket. You just have to kind of search through and find what you need. And of course, you could pull this from a tier 1 platform as well if you are familiar and have access to that. So this is the way you would go about building the workflow. So I'm going to just go ahead and do this kind of as we go along. So we're going to clone the global workflow. This will take a few minutes, and then once we do that, and once it's complete, I'm going to shell into the container, which I've already downloaded onto this machine, so we don't have to wait for that. But I'll shell in and basically show you how to go about building the global workflow. It's pretty straightforward. What I've done is create what's essentially a patch. It's a tar file that you're going to untar into the root of global workflow, and it adds a bunch of like module files and changes some of the other detect machine scripts that are basically throughout the global workflow subrepositories. Ultimately, the idea is to get these merged into all the sub repositories so that we don't have to run a patch. But for the moment, this is the way it's set up to work. So far, it seems to be pretty robust in terms of like people keep updating the global workflow and various components, and it still seems to be everything's working. But the idea here is that I've added a new quote unquote machine called container, and when you set your machine ID to container, it all the modules that are needed within the container are found when you go to build the global workflow with like the build all script. So let's see, this should be done shortly. But so I put this patch in. I just set up a new little directory or a little repo under Noah Epic called Global Workflow Patch. You're going to want to clone that. It just has one file in it. Well, I think it has a README, which is empty. So you're going to clone that, and we're going to untar this GW patch 1.8.0D after we shell into the container or before we do. So let's see, we're almost done. Getting there. It's a lot of repos. All right. So what do we call it? GWW. All right. So let's untar that file. All right. Now I'm going to. So I have already downloaded the container, and it's in my home directory. So we've got it. I find it easiest to set up an environment variable called img to basically point to your Singularity image. So now we're going to run the command to shell in. Just if you're unfamiliar with Singularity, you can kind of shell into a container which is sort of like SSHing into a new machine. I recommend using the -e flag here, which gives you a clean environment within the shell. Otherwise, you'll have some of your host system environment variables kind of contaminating your shell, and that definitely can cause you problems if you're using modules. So highly recommend use the -e. The -s flag says to use a special shell that I added to this container, my bash, and then $image. So that's the name of the image. So that using the bin my bash sets up its sources like the lmod init scripts, and adds the path, the module path to the spack-stack install. So once we do that, I'll show you. We're now in the container. We're still within within this GW demo repo that I just cloned. You can look here, module avail. There's spack-stack or spack intel, so you can load up basically module load modules as you would on any other system. So we got pretty much the entire unified environment installed there, and so now what we're going to do is we're going to just kick off the build process here. So these are sort of the commands that you need to run before you go to build global workflow. You would do something similar on pretty much any tier 1 platform. You're going to specify the home GFS environment variable, machine ID, in this case it's container, source your versions file, and then load up the specific basically modules that are set up for for the global workflow. We have module base container. After that, cd into sork and run the build all, which if we just copy, it will go through all that. This will take like 20 minutes to do, so I'm not really going to do that, or we're not going to wait for that to finish. But I've already built it in another directory, so I'm going to go ahead and change directories to that. So imagine you've 20 minutes in the future, and that build command has succeeded. So we're going to do this again, and I'm not going to build it this time because it's already built, but I do need to reload these module files. Okay, so now, like I said, imagine you've already built everything. If you look in the exec directory, you got a few executables that are there, but most of them are not yet. So we need to run the link workflow script. Before we do that, we're going to need to point to where we've put the fix files on our machine. So in this case, it's just home fix. So I'm going to do that. And then we're going to run the link workflow. All right. Now if we go back up to the global workflow directory, we look in exec, we can see that there's a bunch of new things that have been linked in there. So all the executables that get built by the build script. So what we're going to do now, though, is we want to externalize these. And so I'm going to move this exec directory to something called container exec. You can call it whatever you want. And the idea, though, is that, like I mentioned earlier, we're going to make a wrapper for each one of those executables and put it into the actual exec directory. To do that, we're going to run, I provided these this externalize script in /opt container scripts within the container. We're going to use the -e flag, which will tell the script where to put these the wrapper scripts, and we're going to say put it in exec. It will create that directory if it's not already created, and it will take wildcards, so we can just give. It's best to use like full path names here. I think it still will work with relative, but it'd be better off to use the full path name. So we'll just use all of everything that's in the container exec. We're going to make a wrapper script of, and it'll show you all that stuff. And if we look in there, we can actually even look at one like UFS model. You can see here it's basically a bash script, and it specifies like what the container image is called and where it is located. And then what it'll do here is it sets a bunch of environment variables that are available to within the container. So it sets all like the FI provider path and FI provider, some of these things that are going to be needed by the MPI, but also the path for all the executables that you might need within the container, LD library path, and so forth. And then basically what it will do is then run Singularity with the image name, and this basically is the magic here, where the host system just doesn't even know that it's running a script. It thinks it's running an actual executable. Okay, so beyond that, we're also going to want to do, because the global workflow has a few other things that it likes or it expects on a host system. We're gonna install like wgrib, which we have loaded up as a module right now, module list. And so we're gonna put the wgrib executable in this exec/bin directory, and we're doing that because then we could say the wgrib to root directory is global workflow /exec, and the workflow scripts will find wgrib2 and use the containerized version of it. We're also going to put the prod util stuff, everything in prod util bin, into this as well. So this will add a bunch of things from the prod util, which are also going to be used by the global workflow, or so the scripting part. All right, once we've done all that, we can exit the container, and we're back on the host system. And so now, just going to edit a few things in the defaults for so let's see, that's in parm. And I think, yeah, I've already changed these. So some of these things are not yet set up to work. In particular, the tracker, the Genesis, and Met Plus are not working. So I recommend you change them to no for the moment, unless you want to try to figure out how to get them to work. There's no reason that they shouldn't work. We haven't gotten to that yet. And in this case, I set the the number of hours to run is just 12. So let's keep this, to a reasonable amount of time that it's going to take to run. And the rest of it pretty much can leave alone. And then we're also going to want to look at this host/container YAML file. So that's in workflow hosts. Here, mostly you're just going to want to change some of these, like the dump dir, the home dir, if it's wrong. In this case, yeah, like I had to change it to the environment variable home, because on this machine it's like /export something or other. Set up an stemp and an ptemp directory, and I recommend you change the configure to slurm. It comes out of the box as none. So if you have accounts and queues and all that other stuff on your system, then you're definitely going to want to put that in here. So you can set that up. Right now, we're only supporting C96 and C48. Again, no reason it can't run on higher resolutions. Just we haven't done it yet. So once you have that changed around, we can just go ahead and set up the experiment. So there's a couple things we have to do before then. We're going to set the machine ID. So we're, this is particularly important. Well, actually, like if you're running this, you're going to try to run it on, say, a supported system, but you're going to try to run the containerized version. You might want to just not set your machine ID or set it to the actual host name. But if you're on an unsupported system, you're definitely going to want to set it to container. So, I mean, yeah, so export machine ID, container. We want this global workflow exec, so to be in our path. So we're going to do export path equal, yeah, no, yeah, that's right. So now if we do like which UFS model.x, it's in our path, and so the workflow script will find it. Oh, and here exporting the wgroup2 root will also, this will allow the workflow to figure out where wgroup2 is. So and it's /exec, not /bin, and that way it'll figure it out. Okay, now we can set up the experiment. So we'll, in this case, what we're going to do is we're going to run a GFS forecast only with a cold start. We're calling it C48 ATM. That the app is atmosphere only. We're setting up the resolution, the dates. These are the dates that we've downloaded, com root. And in this case, I have it listed as data. You're going to have to change these things to whatever is appropriate for your system. So we'll run that. And let's see, we're going to call. I'm going to make sure I call it the right thing. Oh, sorry, got to change the workflow. All right. And now we're going to run the setup XML for the same thing. And we're good to go. Now we're going to CD over to and the next thing we can do is run Recoder run. So for those of you who are not particularly familiar with the global workflow, and if you're trying to debug problems as you're going along, when the content that's getting spit out here is, you could basically copy this and put it into a script, and you can now submit that same job with a sbatch stage.sh if you were so inclined. In fact, we'll do it. Let's see. Let's just, yeah. So if we want to look at the log file, we can take a look at it. Everything completed. We got, error code 0. So we'll run the next task, which is the forecast. If we do Recodo stat, we can see that it's submitted and running. And if we go and look at the log file, you could see, that I did neglect to say you need to have your Intel One API module loaded, or at least in your path, so that the global workflow will know where MPI exec is. If you don't have that loaded on the host system, and this will fail. But basically, this goes through the whole setup process, and then it will start running the. Well, I don't think we had gotten there yet, but nope. Once it gets through all the forecast setup here, it will kick off the actual forecast using the containerized version. And you can tell it's a containerized version because you'll see a bunch of Singularity kind of stuff pop up on the screen. So you can see here, there's like the warning about environment variables or whatever that have been set multiple times or something. But yeah, but then it kicks off and starts running. In this case, it's running on 12 cores, so 6. It's a 1x1 layout with 6 write tasks. So yeah, it'll run through, and it's only running for like 12 hours, so it will finish fairly quickly. And then we can run through the next step, and like you would for any normal Recodo workflow. So that's pretty much how it works. There are some potential issues that I will warn you about if you try this on a machine you haven't used before or hasn't been set up previously. You're probably going to need to install a couple of my Python modules. When I set it up yesterday on this machine, I had to install like Python dateutil and xarray. I did that with pip. That works fine under user space. If you don't have Slurm, you can just copy and paste those scripts, and you don't have to use Slurm. You can just execute them. So you can do it sh like that, stage.sh that I created. It would run fine. You can use this Recodo fake Slurm also. You could of course install Slurm if like I've installed it myself on a machine that I have root on. But the Recodo fake Slurm works really well, and that's available now in the develop of the SRW app. And you can just either put a path to that directory, or you can copy that directory out and put it into your like /bin or something like that, or ~bin. As I mentioned earlier, those fix files are huge. So here are some, if you do want to download these things, you can only pull from these particular dates, which are the ones that are going to be used for this, at least this scenario that we're running right now. You can also go further and look in some of those. They have like just massive, like the orography in particular has like, C3000 something or other resolution orography files, which we don't need, and they're huge. So you could avoid downloading those. This is some of the stuff that I think we need to work on figuring out how to, cull down like just a small subset of the fixed files and the initial conditions that can work for maybe C48, C96, and make that easily downloadable for people from S3. And here I put in a few useful Rakoto commands if you are not familiar with it. There's of course Rakoto stat, which will give you the status of your workflow. You can rewind a step that failed if you're not familiar. Basically, you're going to want to pull out. You have to specify the cycle, so you're going to want to pull out this this number over here, the date, and then it wants a task. So you got to give it the name of the task that you're rewinding. This is one I just learned recently, thanks to Alex Burrows. So you can, if your workflow is not completing or not taking the next step, if you run the Rakoto check of that task, it will tell you like what is missing, or what dependencies have not been fulfilled, which can really help. And then if you ran a step by hand and didn't run it through Rakoto, you can force completion of the workflow by running the Rakoto complete command. So just kind of things to keep in mind if you're trying to debug a workflow. So yeah, I guess that kind of sums up the presentation, and I can take questions now if you'd like. Looks like we have a lot of people things in the chat, but Walter, go ahead.
First, we tried to go to that patch repo and get 404.
Oh,
I don't know if it's private or if you gave us the wrong link, but I checked all of no Epic and there's no global workflow patch.
All right, let me see if I can fix that.
And then I saw before at one point you were setting the machine and home GFS and everything. Is something with your patch change that? Because usually build all and link scripts will detect that on its own and you don't have to set anything there. So you had said you need to export several variables and load those containers. So I'm wondering, is that some change you have to make in those scripts?
So
usually that's done automatically.
So it's possible. I am no expert on the global workflow scripting by any means. So I kind of brute force things as with that patch right now. Like, so it goes through, and it should, I think, detect that it's in a container, because I put stuff in the detect machine type scripts that are all throughout. But yeah, just to I guess to be sure, I added that to set the machine ID as container at the top level. I guess that's one of those things you have to maybe check and see if it would work.
It's probably getting overwritten, but we have to see the patch first.
Okay. So this is, maybe I put the wrong, that should be, I just put it in the chat. Is that, if you click on that link, does it work for you?
404.
Really? Huh.
Yep.
Okay, maybe it is private, and that's the problem. So let me.
It works for me.
Oh, really? Okay.
Yeah, me too. I think it's private.
So it must be private, yeah.
There's a lock next to the name, repo name.
Yeah, I see that now. Let's see. I'll have to figure out how to make that public. Because I'm sure I can do that, but. All right, well, I'll work on that. I'll try to get that changed. So If you'd like to see, I mean, I can actually. No, that's not gonna work. I guess we can. This is the list of files that are, sort of in this patch. So there are these container, UFS common container, these Lua files basically that are in there, and modules set up to tech machine, that kind of stuff that's all been added or modified slightly to include containers. There's a few other things like the CMake lists, that need a few tweaks. So that kind of gives you an idea.
Can you do a GIF in the where you have it built so we could just see differences are?
Yes.
I think we actually want to see the changes.
Oh, you want to see
If
the
that's
change?
too much for here, it's fine.
This will only be the top level, but
Yeah, most of it's in some modules, but
it's probably. I know what's going on here. Like, I'm all right. It eventually got done, right? So yeah, some of these are changes that I made explicitly for this machine, like say that UFS NTAS 12. I'm sure there's better ways to do it. Adding like container. Yeah, here I specifically made it into container. So these are the things that definitely, if we're gonna, the idea is to get these changes merged into the how to develop, and they will probably have to be a little bit more refined to make sure that we're we're not over stepping on anybody else or any other platforms or that sort of thing. So let's see. I haven't looked at the questions here.
so I'm fine, Ed. I was gonna. I have one more thing, but you can go.
Oh, sure. Go ahead.
Oh, I was just gonna say one nice thing at some future point when this is kind of all solidified would be to set up a GitHub action to just automatically make a container every time there's a push to develop. That just makes a container with it built even. So it so it's just ready to roll.
Yeah, that's definitely something we could look at. And I think yeah, like the idea of building it and providing it in the container is something we should think about. The thing that I feel helps in some ways by doing it this way is it allows users, particularly like researchers who are like just trying to figure out how this works, to sort of see how the container works itself, see how to build the workflow from source. And then they understand a little bit of like, okay, I got to run this externalized thing to make it available on the host system. If you just provide everything out of the box, I feel like people will not learn as much, I guess. So
okay.
Hendrik?
Yeah, so to counter that statement, I understand what you're saying, Mark, but we're also looking at having the capability of running UFS codes, whether it's the global or something else, literally in the classroom as a black box, all the way down to potentially elementary school even.
Okay.
And so in that context, the progress you made here for researchers is a huge step forward for getting to a sort of black box capability somewhere on a cloud on a cloud resource that we could use in the classroom even way before college. And so I'm really excited to see what you're doing here.
Great. Yeah. I mean, like I said, we certainly could build everything in and provide it in the container. It's going to make the container bigger, but you know, that is what it is. I suppose if we were providing everything in the container, we could probably trim down some of the other things.
Yeah, and it's literally, well, I said it's literally it's just a bit of a specialized application. You probably still want to be able to run low resolution codes and all that kind of good stuff. And with that, you probably can make the footprint in terms of disk space way smaller.
Yeah.
I would not necessarily sort of do your development targeting for that, but keep in mind that would be a very practical application in terms of building the next generation workforce and getting more kids interested in doing our field again.
Okay. Yeah. Sounds good.
Thanks.
Dom?
Yeah, so with respect to building all the stuff automatically in GitHub Actions, we could probably leverage what JCSDA is doing or spack-stack is doing there. So we already build containers nightly, basically. And we can speed that up with, using binary caches and things like that. So if we can incorporate what you've done to build the containers the way you need them to be built, then we could take care of that part and you'd have the container ready and you just have to take it basically and then add the UFS stuff on top of it.
Mm-hmm. Yeah. I definitely the way that these containers are built are considerably different than the way you guys do it, or JCSDA is now doing it, on their nightly builds. But yeah, that would be cool to incorporate that kind of CI stuff into it. That'd be nice.
Yeah, and we run this on self-hosted runners. That's for Christina, who asked the question about resources. That's something that's always possible to use self-hosted runners on a system that allows you to do that. So you don't have to work with free resources on GitHub Actions.
Right.
And also about the containers. So JCSD isn't married to the way the containers are built. This was just the easiest way to get them built. And then, once you've got something in place, you don't change it. Mm-hmm. So if you have something else, I think JCSD would love to have could be loaded and unloaded as needed.
Okay. Yeah. So definitely we'll talk to them. Rahul?
Yeah. Thanks, Mark. Excellent demonstration. Kind of pleased to see that your patches are limited to the workflow, are not extensive. They are in the core workflow, are things that haven't been thought about for a container. The other work is largely facilitated by the use of spack-stack. So kudos to the spack-stack team because it provides a uniform environment to build the gazillion executable dependencies that the application needs. My question, I have two things. First is I would love to see this capability in the develop sooner rather than later so that we can all build on the same platform. Second, I have a question is, what is the size of your container right now? Like if you do a DF on it right now, because you saved your external data outside on the host, you saved the initial conditions on the host, you're running the experiment on the host. All you're leveraging is the image of the container that came with the libraries. And second is whatever you built with the global workflow. So which is not part of your image because
it's on the host.
Yeah, so I wouldn't think that this is more than a few megabytes.
No, the image is pretty big. It's 11 gigs. So
but that's the base image.
That's the image that has the Intel compilers. And Chris, I use I saw this in the chat. I use the Intel Docker image that they provide. So that's the base image. I don't know why that. I think before you weren't allowed to make it available, but it's now freely available to people to use as their base image. So I start with that, and then I build up, add a bunch of extra things that we need for to build spack-stack, and then build spack-stack in there. So
Yeah.
So yeah, it's that whole thing ends up being 11 gigs as a Singularity container.
So on top of that, global workflow should not be more than a few megabytes because it's source code primarily.
Yeah, yeah. I mean, yeah.
Okay, thanks.
Eddie?
Yeah, quick question. So I saw that you built the application in the container, but I thought the containers are not writable.
Well, you're building it on the host system. So yeah, like you basically you clone the the global workflow on the host system. You shell into the container, but you're still using the host system file system.
Gotcha.
And you can write on that. So yeah, that's you can't write anything in the container unless you make it a sandbox.
Yeah.
Right.
Okay.
You shouldn't have to.
Gotcha. Okay, that makes sense. I was just curious. Thank you.
Sure. Krishna?
Mark, great presentation. I just have a question from a community perspective for Linux systems. You mentioned about the slurms dependency, of course. How difficult would be to install Slurm? And if it's straightforward, then is it possible to add some documentation? It's more for some community.
So I'm pretty sure that if you want to install Slurm on your system, you have to have root. But this Rakoto fake Slurm, which is available, and that's what I'm using on this system, which I don't have root on because it's like an EMC machine. I use this, Rakoto fake Slurm, and it just comes with these scripts that are mimic saccount, sbatch, scancel, sinfo, that sort of thing. So it will only run obviously on that node. So like if you had a system that had multiple nodes on it, I guess you'd really either need the sysadmins to add Slurm, or you'd have to have sysadmin app or root access. Chris?
Yeah, I just wanted to let you know that I actually have a containerized Slurm cluster with a spack-stack install in it in a shared volume.
Okay.
So what this allows you to do is you can just, on your laptop, you can create a Docker Slurm cluster, essentially.
Okay.
That makes it look like you have a Slurm cluster with as many nodes as you need. Of course, all those nodes are using however many CPUs your laptop has.
Right.
It allows you to use Rakoto or whatever you want.
Okay, great. Yeah, that's obviously another solution. So that's really interesting. So
It's great for testing in GitHub Actions too. If you don't have, if you want to do it on a regular GitHub runner instead of going through all the pain and suffering of deploying to an HPC.
Yeah. Cool. Oh yeah, Jillian, if you could set that to public, that'd be great. And Dom, on the LLVM thing, I actually did build a container with the spack-stack based on spack-stack 1.8 with LLVM compilers in it, or built on LLVM. Whether that's it was all part of the Intel HPC Docker image, and I did try to build the weather model against it, but it would not run. So that's a different problem.
Yeah, I know that we can use ICX and ICPX, but not yet IFX. We still have to use the old iFort.
Okay, interesting.
But I don't know about the UFS. I know that Dushan recently contributed changes to the UFS to build and run the UFS weather model with with I think all three of the new compilers.
Cool. All right, Jillian says that the repo should be public, so I don't know if anybody who couldn't get to it might want to check again and see if it is available to them now. Chris, did you have another question? Or is the queue just old?
Yeah, no, I was really interested in the fact that you actually have a container that has spack-stack with modules in it, because as you probably know, the SPAC's containerized capability produces an image, a Docker file that just has everything automatically loaded in /opt. So I'm assuming that you made some significant modifications to the Docker file after it was produced in order to create those modules. I'm really interested in how you did that.
Sure. It is completely different than the way that the spack-stack team has done it. It's in a repo also. And yeah, the idea behind it was to make the container look like, you know, a tier 1 platform. So when you shell in, you can load up the modules just like you would load them for, you know, Hera or you know, Orion or something. And so we have those containers, you know, available on the NOAA Docker Hub, and you know, we have a bunch of different ones available, you know, through well, there's 3 of them that are in the S3 bucket right now. There's many different varieties that are on the tier 1 platforms under the Epic space. And let me find the repo that has the Docker files in it.
Yeah, that would be great. I'm really interested in seeing the process that you used to create those, because I wanted to do exactly what you're talking about for my own work for different reasons, but I was getting ready to, you know, go through that whole process of running the commit, you know, adding the commands to the Docker file to generate the modules, and then I'd have to add a modules.yaml file as well, probably. And anyway, no sense in me doing that from scratch if you've already done it.
Yeah, definitely don't need to go back and reinvent that wheel. Here's the link to, so I put these into, like, they're not the most organized in this Git repo, but it's, so the Git repo is NOAA Epic /UFS containers. You want to look for the branch. So the branches are based on generally the type of containers that's being built. In this case, I would recommend Unified 1.8.0, but if you wanted, you know, 1.6.1, there should be a branch for that also. The Docker files that you are interested, or you're going to want, are in under Docker file, or so UFS containers, Docker, and then probably under Unified. So it'll probably be in this path.
Okay, thank you. That's really helpful. Really appreciate it.
Sure. Yeah, if you have questions about it, you know, let me know. I do have, so what I do is I build some of these in stages, and as I get the spack-stack complete, I write it out to a binary cache, which of course is way too big to put into GitHub. So I have those binary caches available. If you wanted to get one, I can put it someplace where you can get to it, and then you can use that as well when you go to build your container. So it'll copy the binary cache into the container to use, you know, while it's building the spack-stack, and then it'll delete it at the end. But that makes your whole process a lot faster.
Yeah, I have my own binary cache on S3 in an S3 bucket that I use.
Okay.
Using Docker secrets and a whole bunch of complicated stuff.
All right. Well, we're definitely over time. If anybody has any questions or other, you know, comments or, you know, suggestions, please let me know. And hopefully some of you get a chance to maybe try this out someplace and let me know what does and doesn't work, and we'll see what we can do. I'm hoping we can have some kind of a release of this capability within the next maybe 6 months. We'll have to work with the SI team and see what we can come up with and what kind of capacity they have to do that. But I think we're making some pretty good progress, and I'm hopeful that we can get people on board and starting to use this software. So thanks for joining me, and I'm sure I will talk to everyone at some point later. Thanks very much.
Thanks, Mark.